New research suggests that many planets previously considered promising for life may, in fact, be far less hospitable. A distant planet might sit in the perfect orbit for life, with temperatures just right for liquid water, but if that world is too dry, it could still be completely uninhabitable. New research suggests that many so-called desert planets may be far less promising than they appear, but new research suggests many of these dry worlds are far less likely to support life than previously thought. A study from the University of Washington finds that an Earth-sized planet needs a surprisingly large amount of water, at least 20 to 50% of Earth's ocean volume, to maintain long-term surface habitability. Astronomers have confirmed more than 6,000 exoplanets, with billions more expected to exist across the galaxy. Many fall within the habitable zone, where temperatures could allow liquid water, but being in the right location is only part of the story. A planet also needs stable climate controls, and those depend heavily on how water interacts with its geology and atmosphere. While water is essential, it does not automatically make a planet habitable. In this study, researchers took a closer look at planets with only small amounts of water to better understand their potential for life. Researchers were interested in arid planets with very limited surface water inventory, far less than one Earth ocean. Many of these planets are in the habitable zone of their star, but we weren't sure if they could actually be habitable. The findings, published in Planetary Science Journal, show that habitability depends on the geologic carbon cycle, a water-driven system that moves carbon between a planet's atmosphere and interior over millions of years, helping regulate surface temperature. On Earth, carbon dioxide released by volcanoes builds up in the atmosphere before dissolving in rainwater. This rain reacts with surface rocks, and runoff carries carbon into the ocean, where it settles on the seafloor. Plate tectonics then push carbon-rich ocean crust beneath continents. Over long timescales, this carbon returns to the surface as mountains form. If a planet does not have enough water to sustain rainfall, this cycle breaks down. Carbon removal through weathering slows while volcanic emissions continue. As a result, carbon dioxide accumulates in the atmosphere, trapping heat. Rising temperatures cause remaining water to evaporate, triggering a cycle of warming that eventually makes the planet too hot for life, so that unfortunately makes these arid planets within habitable zones unlikely to be good candidates for life. Although scientists can detect signs of surface water, rocky exoplanets are still difficult to observe directly. To overcome this, the research team used advanced computer simulations to study how water behaves on dry, desert-like worlds. A nearby example may be Venus. This planet is similar in size to Earth, likely formed at about the same time, and may once have had comparable amounts of water. Today, however, Venus has surface temperatures similar to a wood-fired pizza oven. Standing there would feel like being crushed by 10 blue whales. Future missions to Venus aim to uncover what happened to the planet and whether it ever supported life. These findings may also help scientists better understand distant exoplanets. It's very unlikely that we will land something on the surface of an exoplanet in our lifetime, but Venus, our next-door neighbor, is arguably the best exoplanet analog. Researchers hopes that data from upcoming missions will help confirm their models. This has implications for a lot of the potentially habitable real estate out there. Thank you for watching. If you've enjoyed our videos, subscribe to our channel for there's more to come.